Chapter 6: Information Processing in Dynamical Systems, Foundations of Harmony Theory, by Paul Smolensky, published in 1986, was an influential contribution to the field of cognitive science and connectionist modeling at the time. To understand the context of this work, it's important to consider the state of cognitive science and the prevailing paradigms during that period. In the 1980s, cognitive science was primarily dominated by symbolic approaches, such as classical rule-based systems and computational models based on symbolic manipulation. These approaches viewed cognition as the manipulation of discrete symbols and relied on explicit rules and algorithms. However, these approaches faced challenges in capturing the complexity and dynamism of human cognition. Smolensky's work on harmony theory was a response to these challenges, offering an alternative framework that emphasized the parallel distributed processing of information and the dynamics of cognitive systems. His work aligned with the broader paradigm shift in cognitive science towards connectionism and neural network-based models. The chapter presented the harmony theory framework as a novel approach to modeling cognitive processing in dynamical systems. It provided a computational account of information processing based on distributed representations, parallel processing, and constraint satisfaction. This departure from the traditional symbolic approaches of the time was a significant contribution that aimed to address the limitations of those models. By adopting a connectionist perspective, Smolensky's work aligned with the growing interest in understanding how neural networks and distributed representations could account for cognitive processes. This approach was seen as more biologically plausible, as it drew inspiration from the structure and dynamics of the brain. Moreover, the application of harmony theory to linguistic phenomena, particularly phonology, was a notable aspect of Smolensky's work. Phonology, the study of the sound patterns in language, presented a complex and challenging domain for cognitive modeling. Smolensky's framework offered a new perspective on phonological knowledge and its dynamics, by integrating distributed representations and constraint satisfaction. Harmony theory, as proposed by Paul Smolensky, is a connectionist approach to modeling information processing in dynamical systems, particularly in the context of cognitive phenomena like language processing. The theory introduces the concept of harmonies as representations of the overall activation patterns within a cognitive system. The aim of information processing in this framework is to reach a state of maximum harmony. The theory suggests that cognitive systems tend to settle into states of maximal harmony, aligning with the notion of cognitive optimization. Harmony theory emphasizes the importance of distributed representations and parallel processing. It posits that information is processed in a network of interconnected processing units, often referred to as nodes. Each node represents a feature or concept, and the connections between nodes capture relationships between those features or concepts. The dynamics of the system are driven by a process of constraint satisfaction, where constraints represent the requirements and expectations guiding the processing of information. These constraints can be internal, reflecting the structure of the cognitive system, or external, reflecting the input from the environment. The interaction between constraints and the distributed representations leads to the emergence of patterns that represent the system's response to the input. Harmony theory aims to capture both local and global constraints. Local constraints refer to the individual connections and interactions between nodes, while global constraints capture higher-level patterns and regularities that emerge from the system's dynamics. The theory proposes that these local and global constraints work together to shape the processing and representation of information. Additionally, harmony theory incorporates learning and adaptation. Connectionist learning algorithms, such as Hebbian learning, play a role in shaping the network's connectivity based on the patterns of input it receives. Learning in this framework involves adjusting the strengths of connections to improve the overall harmony of the system. The application of harmony theory to linguistic phenomena, particularly phonology, is a notable aspect of Smolensky's work. The theory offers a unified account of phonological patterns, such as sound alternations and constraints on sound combinations, by integrating distributed representations and constraint satisfaction. The publication of Smolensky's chapter in 1986 helped propel the growing interest in connectionist models and their applications in cognitive science. It influenced subsequent research in the field, particularly in areas such as language processing, cognitive psychology, and neural network modeling. It's worth noting that Smolensky's work in the 1980s laid the foundation for later advancements in connectionism, such as the development of neural network architectures like the multilayer perceptron, and the introduction of learning algorithms like backpropagation. These developments further expanded the capabilities and applicability of connectionist models in various domains. Overall, the publication of Chapter 6, Information Processing in Dynamical Systems, Foundations of Harmony Theory, by Paul Smolensky in 1986 was a significant contribution to the field of cognitive science. It challenged the prevailing paradigms of symbolic processing and introduced a connectionist framework that emphasized distributed representations, parallel processing, and constraint satisfaction. The work influenced subsequent research and contributed to the growing interest in neural network-based models of cognition.